So what affects the motion of a mass in a gravitational field? Well, obviously the strength of gravity and the strength of the gravitational field and the velocity of the mass as it enters the field. Let's consider a spaceship and its motion around the Earth. Have a go at the challenge on the link and look at the shape of the spacecraft orbit at different launch velocities. What happens if you launch at too low a velocity and at too high a velocity? You can see that the spaceship follows two paths when it orbits the planet or moon. It can either follow a hyperbola around the planet, or it can follow a circular orbit. In order for a spacecraft and a satellite to follow a circular orbit, then the gravitational force from the planet must be equal to the centripetal force from the spacecraft. Now, let's look at what affects the motion of a charge in an electric field. Again, obviously it's the strength of the electric field and the velocity of the charge as it enters the field. Let's consider a negatively charged particle entering a positive radial electric field. Have a play with the model in the hyperlink and look at the factors that affect the motion of the particles. If we now think about a charged particle entering a uniform electric field, then we know that it will be repelled from one plate and attracted to the other plate. The factors that change the motion of the charged particle are the potential difference across the plates and the kinetic energy the charged particle has when it enters the uniform field, and the size of the charge on the moving charge. As we know from earlier sessions on uniform circular motion, anything that orbits a body with mass is attracted to the planet by centripetal force. The reason the satellites don't crash into the Earth is because they have velocity that is always perpendicular to this centripetal force. So they are always falling towards the planet at the same rate the planet falls away from them. The same is true for planets orbiting around the Sun. The closer the planet is to the Sun, the greater the centripetal force, and therefore the quicker the angular speed must be. This explains why Mercury has a much shorter orbital period at just 88 days than Pluto, which is about 250 Earth years, because Pluto is much further away. In the same way, satellites have to be put into specific orbits depending upon their use. Create a list of all the types of satellites you know, then discuss what kind of orbit they might be in, i.e. a high orbit or a low orbit.